Hi, in this example, we're going to discuss compositions of two functions at a particular point. As we discussed previously, every function is composed of at least two or more functions, which means there's a graph for these functions. And in this case, we're just going to really find ordered pairs on this new function, f composed of g. In fact, we're looking particularly at the x value 4. The first thing I would do is I notice I have g of 4, f of 4, g of 4, f of 4. I would probably find these values first. Let's find these outputs first. So the first step would be to find f of 4 and g of 4. And so I have f of 4 to be equal to, and then putting it into f of x, I have 4 squared minus 3 times 4. So this is equal to 16 minus 12, which is 4. So f of 4 is equal to 4. And don't forget, I always tell students, like in your mind, always remember that these are just ordered pairs, where this is the ordered pair 4, 4, right? If I needed to plot it on some graph, okay? So now let's go to g of 4. G of 4 is equal to, and I'm using the function g here, so this would just be 4 plus 6, which is 10. So g of 4 is equal to 10. And again, don't forget, this is just an ordered pair on g, right? The ordered pair 4, 10. So keep that in the back of your mind. Just have it in the back like, oh yeah, these are just ordered pairs, So the second part we want to do is, now let's just start evaluating. So if I have, let's say for part A, I have f composed of g of 4. By definition of composition of two functions, this means I'm really finding f of g of 4, which means that I'm really finding f of, well, g of 4 I found, and g of 4 was 10. So I'm really just finding f of 10. Well, that's not too bad because I know what the function f is. It's x squared minus 3x. So this will be 10 squared minus 3 times 10. And this would just be 100 minus 30, which is 70. So f composed of g of 4 is 70. Okay, so there's A. If I went ahead and did B, moving this over a little, B is g composed of f of 4. Okay, well, by definition, this is g of f of 4, meaning that I know what f of 4 is, and really all I'm doing is finding g of 4, because f of 4 was 4. Well, that's not too bad because I also found that previously, right? That's just 4 plus 6, which is 10. So this means that g composed of f of 4 is just 10. So the trick to these is really just rewriting it using its definition and then replacing that inner with what f of 4 or g of 4 is and then putting it into the function. So moving on, if I went to C, which is f composed of f of 4, and you're like, now it's just f of what? Right? But really, by definition, this is just f of 4. And I know what f of 4 is because I found it in the step 1i, which is just f of 4. And f of 4, like we found in 1i, is 4. So f of 4 is 4. And then the last one is going to be D, which is then the g of 4. So the g of 4 by definition is just g of 4. And I found g of 4 in 1i, which was 10. So really I'm just looking for g of 10. And I'm just really putting back 10 into g. So g was x plus 6, so this will just be 10 plus 6, which is 16. So g of 4 is 16. Now, it looks fancy the way we write it mathematically, but again, like I said in 1i, don't forget these are just going to be ordered pairs on these new graphs. Like for A, it's just some ordered pair on this new graph f of g, which would be 470. On the new graph of g of f, whatever that may be, the ordered pair will be 410. If I get a new function f composed of f, I would have an ordered pair 4, 4. If I get a new function g of g, I would have an ordered pair on that function 4, 16. So these are just ordered pairs of new functions that we're composing.